Alright guys, so we are working on objective 225, which is to use and apply the properties of perpendicular bisectors, angle bisectors, medians, and their points of concurrence. So we did talk about altitudes today, and while they are important properties, there's not a lot of algebraic properties that come out of our altitudes other than the fact that they create those 90-degree angles. But our perpendicular bisectors, our angle bisectors, and our medians have some more interesting things happen, so that's what we're going to be focusing our time on today. Okay, so example number 1. We are told that XZ is the perpendicular bisector of YW, and this is an X. Okay, so XZ is the perpendicular bisector, so we know that is a perpendicular, right? They want us to find WZ and XY. So, finding WZ, right here, we want to find this. Well, if we know this is a perpendicular bisector, then the theorem we talked about in yesterday's notes, that any point that lies on a perpendicular bisector is equidistant from the segment that it bisects. So if this is bisecting WY, then this is going to be equidistant from, Z is equidistant from W, and Z is equidistant from Y. So they are congruent. So we can go ahead and set up our solution. So we have 2Y plus 15 equals 9Y minus 13. Okay. And then we go ahead and solve. So I have subtracting my 2, 7y minus 13 equals 15. And then I can add my 13 to the other side. So 28 equals 7y, which gives me y equal to 4. Alright. So I can use the fact that they're equidistant to solve for my y, but then they wanted me to find WZ, right? So then we want to do 2 times 4 plus 15. So 2 times 4 is 8 plus 15, and there we have our 23. Okay? So there's our answer for WZ, and that again is using the fact that any point that is on a perpendicular bisector is equidistant from the segment that it bisects. Now we want to find XY, which is this little segment here. So this is going to be using just the straight up definition of a bisector, that if this is a bisector, we know it is bisecting these segments, WX and XY. Those are going to be congruent. So we have then X plus 5 is equal to 3X minus 5. Solving, we find that 2x is equal to 10, therefore our x is equal to 5. Right. And again, they want us to find xy, not just solve for the variable. So substituting it back in, we have 3 times 5 minus 5, which is 15 minus 5 equal to 10. Okay. So again, just a few different ways we can use perpendicular bisectors algebraically. The one that we typically forget about is the fact that any point that lies on the perpendicular bisector is equidistant from the points or the segment that is being bisected. So usually we don't have a problem with number 2. We remember what bisecting means, but when we have our perpendicular bisector, we need to remember that this property also holds. Okay. So moving on, they want us to find the value of x. Okay, we're not told whether this is a perpendicular bisector, an angle bisector, a median. We really don't know. So let's look at our diagram and figure it out. And pretty quickly we realize we have 2 angle measures that are congruent, which means this ray in the middle here is bisecting this larger angle. So this is an angle bisector. So what can we do if we know that? Right? Well, if we pick a point on an angle bisector, then we know that it is equidistant from the two rays that make up the angle, right? Why is this? Well, we know that the shortest distance between a point and a line is a perpendicular drawn from the point to the line. So if we draw those perpendicular lines in, then we have the shortest distance from this point to that line, and since this is cutting through the middle of the angle, it's also cutting through the middle of the rest of our angle. So we can then conclude that 10 and x plus 3 are equal to each other. So using the fact that we know that the angle is being bisected, we can then say, all right, well, these lines drawn to the end of the angle is also. So my x is 7. So fairly straightforward, but just need to recognize that this is an angle bisector, therefore this holds true. Okay. The next example is taking the converse of that. Here they're showing us that we have two segments that are drawn perpendicular from a point, and they're marking it as congruent with those tick marks. So we know if the shortest distance from a point to a line is congruent, then from that we also know that the angles are congruent, and therefore this is an angle bisector. So we can then solve 6x plus 14 equals 9x minus 1, and again solve. So we have our 3x equals 15, and finally 5 equals x. And here they were just asking us to find x, so we really didn't need to worry about substituting it back in. Alright, so our final example is a little bit trickier, right? It's not as obvious. So here we have triangle ABC, and they're telling us that D is the centroid. Now we need to remember what centroid is the intersection point of. Okay, so remember from today in class that centroid is the point of concurrence of all the medians. So now we know that we're talking about medians, which means here we have congruent parts. So G is the midpoint of AC, E is the midpoint of AB, and F is the midpoint of BC. We're going from the vertex to the midpoint in order to create our centroid at point D. The other information that they're telling us is BD is 12. They want us to find DG, which is this other part of that median, and the entire length of median BG. Okay? Well, in order to solve this, we need to know one more theorem, which is the concurrency of medians theorem. Right? This states that the medians of a triangle intersect at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. Okay? So, what they're really saying here is that BD is 2/3 of the length as BG. Alright, so if this is 2/3, then my DG is going to be 1/3 of the entire length. Well, we know that BD is 12, and they want us to find this shorter half. Right? So, BD is going to be 2/3 of the entire median. Right? Well, we don't know what the entire median is, but we do know that BD is 12. So if BD is 12, equal to 2/3 times our segment BG. Right? Now we can multiply by the reciprocal to get rid of our fraction. And we end up with 18 equals BG. Right? So again, 18 is BG. This is the entire length of the median. So great, we found BG, we found the whole length. Now they still want us to find this shorter part. Right, well, DG is simply going to be 18 minus 12, which means that DG is 6 units long. Okay, So, make sure you understand these properties. You understand that we can set things congruent because of the equidistance. We can set these congruent because that's the definition of a bisector. You need to know the properties that form because of angle bisection and the properties that allow us to assume things are angle bisectors. And then finally, which is the trickiest of the three, the property of the centroid, or the centroid theorem. If you have your centroid, the longer part is 2/3 as long as the shorter part. Sorry, 2/3 of the entire. So this is 2/3, this is 1/3. Okay, so make sure you are finishing up the lesson quiz for today, and I'll see you guys on Monday.